Whenever you have a sample of gas in a container that's not rigid, this one's a balloon, the example in the problem is a bag of chips, then this can stretch. Which way does it go? Does it go in? Does it go out? That's determined by the comparison of this outer pressure, which is almost always the atmosphere, and the inner pressure. In this case, the inner pressure is helium, but it could be any gas. They don't put helium in a bag of chips. That's irrelevant. Which pressure is bigger determines which way this wall moves. Does it go in? Does it go out? Does it just stay the same? When the forces are balanced forces, which is almost always the case, the volume remains the same. So when you look at a balloon and you say it's not growing, it's not shrinking either, it's because the outer pressure and the inner pressure are the same. Typically, we're at equilibrium when this is 1 atm, and the inner pressure is also 1 atm. That reaches an equilibrium, and the balloon's volume stays constant. Now let's look at the actual bag of chips. I'm using a balloon to represent the bag of chips. The problem tells you, and I'm hoping this is logical, that when you go up a mountain, there's less air pressure. The air is thin. So, used to be a balance of forces with 1 atmosphere inside and out. But now it's not a balance of forces, so of course the larger pressure inside causes the balloon to expand. So that's what explains the phenomenon. But that's not the question. The question is what happens to this internal pressure here? Does it go up? Does it go down? Does it stay the same? Does it stay at 1 atmosphere? The answer is no, because as these particles get farther apart, they're more spread out. And as they're more spread out, then their pressure decreases. So instead of staying at 1 atmosphere inside, so this will be less than 1 atmosphere in the end, in the expanded state. The molecules spread out, their pressure goes down. The bag expands until the pressure outside and the pressure inside are balanced. So if the pressure outside due to the high elevation is less than 1 atmosphere, then the bag expands until inside is also less than 1 atmosphere. Inside is the same as the outside. This is when it reaches equilibrium. That explains the answer to the question. It's less than 1 atmosphere as the gas expands.